Today, we're going to learn about solid programming principles with a guitar. This is a Marshall guitar amp, and we're going to use this today to kind of represent different concepts in software programming, such as interfaces, classes, and things like that. So what is solid? Well, it's an acronym. The S is for single responsibilities for classes, the O is for the open-close principle, the L is for the Liskov substitution principle, the I is for interface segregation, and D is for depend only on abstractions. So the idea with the single responsibility principle is that each component of the guitar amp is responsible for one thing and one thing only. The speaker does its thing, the amplifier provides the correct voltage, the effects loop modulates the signal, and so on and so forth. So in your software patterns, you want to make sure that each class really only does one thing and one thing only. It's okay to have a ton of classes that are much smaller than it is to have one class that does everything. Hey gang, okay, so what we're doing here is we're looking at Visual Studio, and we're going to look at the single responsibility principle with C# through guitars, but we're looking at a class that sort of models the guitar amp. Now at first glance, you may look at this and go, okay, well, it's not implemented. Yes, Kevin, that's not right. The idea here is we're not worrying about the details in this particular sample here, so what we should be looking at is when we model a guitar amp, did we kind of model it out correctly? Have we given the right amount of stuff to it, the wrong amount of stuff? Of course, that's very subjective, but I'll give you my take. So if we look at this guy here, we have guitar amp. We can do volume up, volume down, add special effects, output to the headphones, the signal, or maybe handle the foot switch. There might be some other things, but we don't have to cover everything. So at first I would say, okay, yeah, that sounds very guitar ampy stuff. But what I would argue with the solid principles, or at least the single responsibility principle, that we're doing too much here in one class. We're handling volume, we're handling special effects, we're doing stuff with the headphones, and we're outputting, or we're handling what happens when you push the foot pedal. So how would I do this in a more solid way, or at least a single responsibility way? And honestly, what I would do is I would group these two into volume control, this into a special effects component, this one into maybe the output component or something to that effect, and this one a foot switch component. So let's do a little bit of work here to get an idea here. And so what I want guitar amp to be is, rather than, hey, do each and everything, I want it to be a composition of components. So the first thing let's kind of model out 1, 2, 3, 4 things real quick. So the first thing I'll do is I will add a volume component. Of course, you can name it whatever you want. Naming is hard, right? So if we take these guys back out of here and we stick this here, this class, the volume component, now only handles volume up, volume down, maybe anything volume related for the most part. Of course, we can functionally decompose that more in the future. If we go back here, let's have a special effects component. So if we add a new class, special effects component, and we'll pull this guy back out of here and put it in here. So maybe we'll do more than one special effects thing, but for now we'll just put it in here, and we can again functionally decompose that later if we decide to do so. Now let's add a headphone component. Boom, here we go. We'll take you out of here and we'll put this here. And it looks like we have one more component we need, and that is the foot switcher. So if we add, I'm just going to call it the foot switcher. It's a very technical term. Cut that out of there. And there we go. So you may be thinking, great, Kevin, now we have a class that does individual things, and then this guy does absolutely nothing. What did we really achieve? Because now I have everything all over the place. So what I would do is I would add a constructor here. Now I'm kind of tipping my hand as far as dependency injection goes. It is one of the solid principles. But for now, let's just put this in here. And let's see, we're going to have a volume component. Now we're going to have a headphone component. These can be in really any order we want. This one's going to be a foot switcher. Let's have some special effects. So you've got 1, 2, 3. Do we have them all? 1, 2, 3, 4, 5. I think so. Let's kind of prettify it just a tiny bit here. Then we'll do some resharper magic here to inject those. Oops. Pardon me while my computer has a mind of its own. What I'm doing is I'm just initializing through the constructor here all of our components. So the implied thing is that when I want a guitar amp, that you have to give me each of these components. So that makes guitar amp functionally a wrapper or an enclosure. So if it were a real world item, it would be, you know, just the wooden box basically that houses the speaker, that houses the amplifier, that houses the knobs, etc., etc. So then if we were to come down here, maybe guitar amp has its own particular method, and we'll call it play awesome, because we don't play any other guitar. And we'll do volume component dot volume up, and let's do that a few times because we like rock music. Let's do something with the headphones. Yes, let's put on some headphones. Let's do something with the foot switcher. So, of course, we'll make that cooler one day when we say, okay, let's add lots of, let's go to the distortion channel, and then special effects. Let's, if it's worth overdoing, it's worth overdoing with special effects, and there you go. So, essentially what I can do is now I functionally decompose these into components. However, the astute watcher will notice that I didn't use any abstractions for these, but we'll cover that in a little bit. Now let's talk about the open-close principle. Now the open-close principle, if you interpret it very strictly, is basically once you complete a class, you can't modify it. The only thing you can do is try to extend it. So either the class has to have some sort of extensibility to it or some way to inject different functionality, otherwise you can't modify it. However, my interpretation of the open-close principle is, well, just that, my interpretation. So I take it to mean that if I own a class, you bet your ass I'm going to be able to modify it. It's my class. But I have to be very careful, because if I have consumers in my class, now I have to worry about breaking changes. Take, for instance, a third-party DLL. If you wanted to modify its behavior, you're kind of limited if all you have is the DLL. What you could do is you could try to decompile it, try to modify it, and try to recompile it and put it back into your system. And then when it comes time to upgrade that DLL, you're going to have a real hard time doing the same process over and over again. Even if it's open source, I would kind of recommend that you don't run your custom build, because you are violating, in my opinion, the open-close principle. Because, yet again, when the original manufacturer makes a modification and sends that out, what are you going to do? You're going to have to rebuild that and do a custom build again. Okay guys, we're back here with our guitar amp, and we want to kind of address the open-close principle. And for exercise purposes here, what we're going to do is we're going to take the volume component and make it so that if somebody wants to extend that, it's a little more friendly, because again, with the open-close principle, the idea is when somebody dreams up of a new thing that they want our component to do, we don't want to really first go to the class and start modifying. What we want to do is possibly extend it. So if this is my code and only me, I'm working with this, I'm probably going to go edit the code. However, at some point in my software career, I hope to ship the class guitar amp. And at that point, the person who is using this guitar amp will no longer be able to get into the code, because all they have is a DLL. So it's incumbent upon me to provide some sort of extensibility. So let's see, one of the first things we can do here is we can go to the volume component itself, and then we have this volume up and volume down. So this makes an assumption right now, and this basically says, okay, you're always going to do volume up or volume down, or in this particular way. So if we add the virtual keyword here, now somebody is going to be able to override this in a derivative of this, so somebody inherits it. So let's go ahead and inherit off this. So we're going to add another class, and we're going to call this one the super loud volume component, if I can spell correctly. And the super loud volume component, it's going to inherit off the volume component. And what I'm going to do here is I'm going to override the volume up. And when somebody goes volume up, if true, that we want the volume to be 11. And then what we can do here, when somebody has their own guitar amp, since we use constructor injection here, they'll be able to do another guitar amp. So let's go here and just kind of new one of those up for now. New guitar amp. And what we can do is we can pass our new super loud component in there, of course, and all the rest of the components. And because we've given them a way to override the volume up here, this is one way to extend without modifying the actual base class there. So the moral of the story here is just give ways for people who are going to use your stuff to be able to extend the functionality so they can do whatever they need themselves. Of course, there's a zillion ways to apply extensibility to these other classes, so this is just a token example for right now, but let's continue on. So if we were to look at the guitar amplifier again and kind of look at it through the lens of the open-close principle, I would say this, that the vendor itself has sealed pretty much everything in here, and the only bits that they want you to change would be things that are exposed by these interfaces or the inputs. And so there's where we're going to stick your foot switch, your inputs for your different instruments, and then down here you may have different things like your headphones and a CD. There's also usually things on the back of the amp that would allow you to change out your effects loops and things like that. Next up is the Liskov substitution principle, where it states if I take class T and subclass it to another class, wherever I needed class T, the subclass should work in there no problem. And if we look at a guitar amp example, if I take a guitar and plug it into an amp and it works, I should be able to modify that guitar slightly, and as long as it still outputs through that guitar cable, it should work in the guitar amp no problem. So we're back in our guitar amp here where we have our new super loud volume component, and we're going to talk about the Liskov substitution principle. So in general, the way polymorphism works is basically if you have a base component, which we'll call this one our base component, the volume component, and we inherit off of that into our new component, which is our super loud volume component, we should be able to stick that wherever volume component is required, which is what allowed us to do that. The compiler's happy. If we go back to the base class, yay, it's happy as well. But we want to use the super loud volume component because we are rock stars and we need it really loud. However, there's one more component to the Liskov substitution principle, and that is there's a behavioral component. So in general, hey, this would be fine. When I turn the knob to volume up, I should expect the volume to go up. But if I then come in here and I say, you know what, let's go volume down, and let's make it work that way, the code will work. However, the intent of the super loud volume component is in contrast to what the volume component was actually trying to do. And that would actually break the Liskov substitution principle. So the interface segregation principle is kind of implying, at least to me, that you shouldn't really combine unrelated functionality in a single interface. So if you take the inputs and the outputs, they kind of do two fundamentally different things. Now, you see out in the wild where you have the microphone jack and the speaker jack combined into one cable, and that's fine, it'll totally work. But if one were to go bad, so let's say just the microphone and not the speaker, you still have to replace both of them, at least at a port level. I think the interface segregation principle is telling us that you should probably have the inputs separately from the outputs. All right, we'll try to keep this one short. So for me, the interface segregation principle is basically the abstract version of the single responsibility of classes. So essentially what we're going to do real quick, we're going to create an iGuitar amp, as you can see here, and we're only going to put the things that are truly core to what's needed in this interface and put that there. We're going to be play awesome. We'll go back here. And iGuitar amp. So iGuitar amp here is a small interface, and the idea here is, again, you don't want 100 things here. I've seen 100 things in one interface before, and the challenge for anyone consuming or trying to implement your interface is if there's 50 things that don't matter, or 50 things that are just all over the place because they have to do with this, with that, totally unrelated things, it's really going to frustrate the end user. So the idea here with the interface segregation principle, keep it simple and keep it small just like you would your classes. Now finally we have D, which is depend on abstractions. We're going to use the guitar jack, which looks like this. It's a 1/4-inch jack. And we're going to call that the interface, which will go into the guitar amp input. If I weren't able to have a removable jack like that, each time I play guitar, I would have to hardwire it in there. And then if I wanted to switch the guitars, or maybe I play a bass through here, I would have to then desolder it, something like that, and then re-hardwire it back to the guitar amp. So we're on the home stretch here with solids, so we don't want to depend on concrete classes. We want to depend on abstractions. So volume component, headphone component, foot switcher, special effects components, those are all concrete classes. Now, as we showed earlier, you can extend these and then still pass those in through polymorphism. But what we really want to do is depend on abstractions, and that'll help us out big time when it comes to unit testing, or if you just simply had dependency injection through a container. So the first thing I'm going to do is I'm going to switch out volume component with an abstraction for the volume component. And for that, I have two options. I can add a abstract class or an interface. I tend to go with a interface most of the time, and then I use an abstract class if I want to have a baseline or a default implementation of my component. So the two things that the volume component should know how to do is volume up and volume down, and this will create a contract because that means everything that implements volume component will have to implement volume ups and volume downs. So if I take the volume component here, or the interface, add it here, make sure the compiler is happy, I now need to go out here to my guitar amp and say, hey, Mr. Guitar Amp, you need one of those, and you need one of those. And now we depend on the abstraction. So when it comes to unit testing, which isn't covered here, we can easily mock those out or switch it out or something to that effect, as long as it implements two particular methods here. So let's do one more just for fun. So we're going to take the headphone component, and we'll add a class here, or actually an interface, and we'll call this one iHeadphone component. And what does our headphone component do? Let's see here. Well, what does it currently do? So if I go to this one here, this one outputs to the headphones. Got it. So if I put this in the interface, great. So now I can put iHeadphone component in the other one. However, I do want to show one wrinkle on this. Let's add an abstract class. So we'll call this headphone component base. And this right here will inherit off of or actually it needs to implement, not inherit, iHeadphone component. And I can use ReSharper to kind of get going here. And what I can do is I can say, you know what, I want you to have a baseline implementation, and it does the outputs. And there's a few things I can do. So I can take this here, go back to my guitar amp, right here, and I can say, you know what, depend on this abstract class. So we do need to be careful here, because what we do here when we put in an abstract class here is we say, you know what, you can't just purely depend on a interface. You're depending on a particular implementation of that particular interface. So what I like to do is, rather than actually put the headphone base here, I will do the iHeadphone component here and here. And that way, if somebody were to use a baseline implementation of this, and let's make this abstract, because this actually isn't an abstract class until you do that. Let's make this virtual. And let's create another class that is super awesome headphone component. And this one will be the concrete implementation of that guy there. And if you notice, I don't have to actually implement that interface there. So if I now go back out to my program here, I can't use that guy anymore. So let's fix that up, because you need to be an headphone component. Yes. And we'll go here. This should make that happy. However, if we want to use our baseline super awesome component one, we can, and that should all work. Polymorphism for the win, and inheritance, and all that fun stuff. Abstractions, awesome. This is starting to look very solid in the code. And of course, you can take this to the nth degree. One thing I guess want to talk about while I have your attention is you can really start getting a bunch of dependencies here through the constructor. So one way to kind of avoid that code smell is to then start combining things in subcomponents. So you might take your super loud volume component and your super awesome headphone components and reason that they're both audio components. Rather than add those together in the same class, you can create an intermediary interface abstraction class and maybe call it your audio components, which has two subcomponents, which would be your volume component and your headphone component. And you can really start whittling this down and get it much, much more manageable. All right. Hey guys, thanks for watching Programming Solid Principles in C# with guitars. And I had fun. I hope you did too. If you have any questions or comments, make sure you hit me up. Thanks. Bye. Hey guys, thanks for watching, and make sure you subscribe.